Impulse and momentum. In the previous lecture, we learned that momentum is the product of mass and velocity. Mathematically, momentum is P is equal to m into v. We know that velocity is a vector quantity, hence momentum is also a vector quantity. Now let me teach you that how can we calculate momentum. Let's consider that a mass of 50 kg is moving in this direction with a velocity of 70 meters per second. The momentum of 50 kg object is calculated as follows. We know that P is equal to m into v, where m is the mass of an object and v is the velocity of an object. Hence P is equal to 50 kg into 70 meters per second. As a result, we get P is equal to 3500 kg meter per second. Now let me teach you the basic concept of impulse momentum theorem. Let's consider that a football of mass m is moving in this direction with initial velocity vi. Suppose an external force F acts on this object for short time t. As a result, the initial velocity vi of the object of mass m will be changed and object will start moving with final velocity vf. Thus the force F changed the initial velocity vi of the object into final velocity vf in short time t. Or you can also say, if the object hasn't experienced force F, its velocity wouldn't be changed and it would be moving with initial velocity vi. Now, here we learn the magic that F has changed the velocity. As a result, acceleration A is produced in the football. Now, according to Newton's second law, F is equal to ma. You may ask why I am stating here the Newton's second law. It is because Newton's second law gives us this relationship between force, mass and acceleration. That is why I write F is equal to ma. Thus F is the force which is acting on the football, m is the mass of the football, and a is the acceleration which is produced in the football. Due to force F, or change in velocity. Let I call this equation number 1. According to first equation of motion, A is equal to Vf minus Vi divided by change in time. Here A is the acceleration of the football, Vf is the final velocity of the football, Vi is the initial velocity of the football, and T is the time in which velocity changed of the football. Let I call this equation number 2. Now let me take you to the start of the lecture. I told you that momentum P is equal to mass into velocity. Momentum depends on mass and velocity. When mass changes, momentum changes. Or when velocity changes, momentum changes. Here in this example, the mass of the football is constant, but the velocity of the football has changed from Vi into Vf. Thus the momentum P of the football has also changed. Therefore, the initial momentum of the football is equal to m into Vi, where m is again the mass of the football and Vi is the initial velocity of the football. As the velocity of the football changes, so its momentum changes. Therefore, the final momentum Pf of the football is equal to m into Vf, where m is again the mass of the football and Vf is the final velocity of the football. Now look at equation number 1 and equation number 2. We are putting the value of acceleration A in equation number 1. Thus we get F is equal to m into Vf minus Vi divided by change in time. Or F is equal to mVf minus mvi divided by change in time. Here mvf is the final momentum of the football, while mvi is the initial momentum of the football. Thus, we can write F is equal to Pf minus Pi divided by change in time. Or simply you can say force is equal to change in momentum divided by change in time. Thus, we learn that force F on the football didn't only change the velocity of the football, but force F also changed its momentum and time t. Or we get another definition of force, which is force acting on a body doesn't only change velocity or produce acceleration in a body, force also changes momentum of the body. Now, if I shift time t to the left hand side, it will become F into t is equal to change in momentum. Now, the product of force and time in physics is known as an impulse. Impulse I is equal to F into t. The SI unit of impulse is Newton second. Remember that impulse is equal to change in momentum, or impulse changes the momentum of an object. Now let me teach you that how can we calculate impulse in physics on an object. Suppose that an object is moving in this direction. Let the initial velocity of this object is Vi is equal to 20 meter per second and its mass m is equal to 30 kg. Now force F is equal to 30 Newton acts on this object for time t is equal to 5 seconds. If I ask you to find the impulse I on an object, the change in momentum of an object, the final velocity Vf of an object, and also the final momentum Pf of an object, will you calculate all these variables? I hope so. Let me calculate it for you. We know that impulse I is equal to F into t. Hence, impulse is equal to 30 Newton and to 5 seconds. We get I is equal to 150 Newton second. As we learned in the previous section that impulse I is equal to change in momentum. The impulse on an object is 150 Newton second, while the change in momentum of the body is also 150 kg meter per second. Hence, impulse I is equal to 150 Newton second and the change in momentum is also equal to 150 kg meter per second. Now, let me calculate the final velocity. We know that change in momentum is equal to mass and to change in velocity. Change in momentum is equal to m into Vf minus Vi. Thus, change in momentum is equal to 150 kg meter per second is equal to 30 kg and to Vf minus 20 meter per second. Hence, 150 divided by 30 is equal to Vf minus 20. R5 is equal to Vf minus 20. Our Vf is equal to 20 plus 5. Our Vf is equal to 20 meter per second. Thus, the final velocity of the object is 25 meter per second. Now, what about the final momentum Pf of the object? We know that Pf is equal to mvf. Hence, Pf is equal to 30 kg and to 25 meter per second. Thus, Pf is equal to 750 kg meter per second. Therefore, the final momentum Pf of an object is 750 kg meter per second. Thus, we calculated the impulse on the object, and that is 150 Newton second. The change in momentum of the object, and that is also 150 kg meter per second. The final velocity of the object, and that is 25 meter per second. and the final momentum of the object, and that is 750 kg. At last, let me teach you one important example of impulse in everyday life. It is the car's airbag system. We use car's airbag system in order to reduce the damage or injuries of the passenger or driver during accident or collision. Now let me explain it according to physics. As we know that impulse I is equal to force into time, or F is equal to impulse divided by time. Now during accident, the airbag increases the time to stop the motion of drivers or passenger toward the dashboard. Or you can say that the time of impact is increased between driver and dashboard. Now when the time is increased, as a result, force F on the driver would be decreased. Smaller force will cause minor injuries. Now if there is no airbag, the time of impact would be smaller. As a result, force would be large on the driver or on the passenger. Thus it will cause severe type of injuries. Change in momentum or impulse changes the momentum of an object.